Hello everyone. In this video, we are going to discuss some of the multiple choice type questions related to interference. Question number 1 is light waves are. Four options are given: longitudinal waves, transverse waves, both A and B, none of them. So as you know that light is an electromagnetic wave, and in light wave, electric field and magnetic field vectors oscillates perpendicular to the direction of propagation of light. Therefore, we can say that light is an transverse wave. So the option number B is correct. Next question is, which of the following does not support the wave nature of light? Four options are given: interference, polarization, Compton effect, and diffraction. So among these options, interference, polarization, and diffraction supports the wave nature of light. It is only Compton effect that supports the particle nature of light. Hence the correct option is option number C. Next question is, colors in thin films are because of. Four options are given: dispersion, diffraction, interference, none of them. Actually, colors in thin films are mainly due to the effect of interference. So the option number C is correct. Next question is, a phase difference pi between the interfering beam is equivalent to path difference. Four options are given: first option is 2 lambda, second is b lambda, third is lambda by 2, and the fourth is none of them. As we know that the relation between path difference and phase difference can be written as this is the equation which relate path difference with the phase difference. If the phase difference is pi, then we can write lambda upon 2 pi into pi. So pi will cancel to pi. So the corresponding path difference will be lambda by 2. So the option number C is correct. The next question is, in reflected light, the central fringe of Newton's ring is. First option is dark, second option is non-uniform, third option is bright, fourth option is none of them. As we know that the path difference between rays R1 and R2 in Newton's ring setup is given by the expression delta is equal to 2 mu t cos R plus lambda by 2. At the point of contact, that is point A, T thickness of the film will be 0. Hence, we can write path difference delta is equal to lambda by 2. So, the rays reflected at point A will have a path difference equal to lambda by 2, and it is the condition of minimum intensity. Hence, the central is part of the ring will be dark. So, option number A is correct. The next question is, in Newton's ring experiment, the diameter of dark ring is proportional to. Four options are given. First is odd natural numbers, second option is natural numbers, third option is even natural numbers, fourth option is square root of natural numbers. As we remember that diameter of the mth order dark ring is given by the expression square root of 4m lambda r. Here r is the radius of curvature, lambda is the wavelength of the light, m is the natural numbers. So clearly dm is proportional to the square root of natural numbers. So the correct option is option number D, that is square root of natural numbers. Next question is, extended source is needed in. Four options are given: Young's double slit experiment, biprism experiment, Newton's ring experiment, none of them. The correct option is Newton's ring experiment, because extended source is required only in Newton's ring experiment, not in biprism, not in Young's double slit experiment. Next question is, intensity of light is proportional to double of its amplitude, square root of amplitude, square of amplitude, none of these. As we know from electromagnetic theory, the intensity is related to the electric field amplitude by the relation 1 by 2 epsilon 0 c E square, where E is the electric field amplitude. So we can say that intensity is proportional to the square of amplitude. So option number C is correct. The next question is, which of the following methods are based on division of amplitude? Four options are given: Newton's ring, Michelson interferometer, both A and B, none of these. Actually, both in Newton's ring experiment and Michelson interferometer experiment, interference is obtained by the division of amplitude. So option number C is correct. Next question is, which of the following methods are based on division of wavefront? Four options are given: Young's double slit, Newton's ring, Fresnel biprism, and the fourth option is both Young's double slit and Fresnel biprism. So here, Young's double slit, in Young's double slit experiment, interference is obtained by the division of wavefront. In Newton's ring, interference is obtained by division of amplitude. In Fresnel biprism, interference is obtained by division of wavefront. So we can say that both A and C is correct. So the correct option is option number D. The next question is, what is the actual shape of interference fringes in Newton's ring experiment? Four options are given: circular, elliptical, parabolic, hyperbolic. In Newton's ring experiment, one used plano-convex lens and a plain glass plate. The locus of the points of equal thickness lies on a circle. Therefore, the actual shape of interference fringes in Newton's ring experiment is circular. Hence, the option number A is correct. Question number 12 is, the phenomenon which cannot be explained by the wave nature of light is. Four options are given: interference, photoelectric effect, polarization, diffraction. So among the given options, interference, polarization and diffraction are explained by the wave nature of light. So the correct answer is photoelectric effect. Photoelectric effect is explained by using the particle nature of light. The next question is, in which of the following the interference is produced by the division of amplitude? Four options are given: Light's mirror, Newton's ring, Young's double slit, Fresnel biprism. Among the given options, only Newton rings. In Newton rings, the interference is produced by division of amplitude. So the correct option is option number B. Next question is, when monochromatic light is replaced by white light in Fresnel's biprism arrangement, the central fringe is. Four options are given: dark, colored, white, none of these. Actually, in central fringe, all the component of white light reaches at theta is equal to 0, so the central fringe will be again white. So the correct option is option number C. The next question is, in Newton's ring arrangement, bright and dark rings are obtained using sodium yellow light. What happens if the top surface of the glass plate on which the lens is kept is highly silvered? Four options are given. First option is fringes will disappear. Second option is fringe will remain unchanged. Third option is fringe will decreases, and fourth option is none of these. So the correct option is fringe will disappear. The reason behind this result is, look at this diagram. Here R1 and R2 interfere to give the interference fringes. But if we will use highly silvered glass plate, then in that case intensity of R2 will be very high compared to R1. Hence we will not get a good contrast in the bright and dark fringe. Hence it will appear like there is no fringe pattern formed. Hence the correct option is fringes disappear. Thank you so much for watching and listening this video.